The topic that we are going to cover is paper 5, question number 1. First of all, this question is about
I knew it. He was cheating.
it is about investigating it is about investigating a relation. It is about investigating a relation between two variables. Basically, a relation will be suggested. Basically, a relation will be suggested between two variables which you have to investigate and you may have to find some constants. Some example relationships are, for example, if examiner asks you to find if examiner asks you to find sorry if examiner asks you to design a lab experiment to investigate whether H is proportional to E square. Here H is equal to heat, E could be pressure of the gas to a gas heater. Now this relationship could be correct or it could be incorrect. Your job is just to design an experiment by which we could check the validity of this given relationship. Or another example of paper 5 question 1 could be, for example, the second example of question number 1 paper 5 is, the question could be, it is suggested that it is suggested that the the resistance of a semiconductor it is suggested that the resistance of a semiconductor depends on its temperature in degrees Celsius. It is suggested that the resistance of a semiconductor depends on its temperature in degrees Celsius. According to the following equation, and the equation is R is equal to R naught e power minus k times capital T. Here capital T is in degrees Celsius. If we define the variables, T is temperature in degrees Celsius. R is resistance of a semiconductor at T degree Celsius. R naught is a resistance at 0 degrees Celsius. R naught is a resistance at 0 degrees Celsius. K is a constant. So we have to relate two things. One of them is the temperature, and the other thing is resistance. So we want to relate the temperature with the resistance. For this purpose, before anything, we'll go with rough work. The rough work will be plan a straight line graph. The first step that you have to take is you have to plan a straight line graph. And first thing is plan a straight line graph. Then how will you plan a straight line graph? Basically rearrange the given relation if it's non-linear. You must rearrange the given relation if it is non-linear. So plan a straight line graph by you need to rearrange the given relation or equation if it is non-linear. For example, let's see example equations and how you will get a straight line graph. Access to achieve a straight line graph. For example, you have this relationship, number one. H is equal to K times P square. Your y-axis must be H. Your x-axis must be P square. And then your gradient would be K. So this is y-axis, this is x-axis, and this is the gradient. To achieve a straight line graph, this is the whole story. In this way, you can get a straight line graph. If you have another relation, for example, if the relation is, for example, r is equal to r naught e power minus kt. When you have exponent, you have to take natural log. Always memorize that whenever you have exponent, you are supposed to take natural log. Now, if you take natural log on the two sides, natural log of r is equal to natural log of r naught e power minus kt. In fact, t was capital, sorry. T was capital. So r naught e power minus kt, and it will become natural log of r is equal to natural log of r naught minus natural log of e power minus kt. So from here, sorry, plus. Power in the log becomes the coefficient. Now it will become natural log of r is equal to natural log of r naught minus kt times natural log of e. So it will become natural log of r is equal to minus kt natural log of e plus ln of r naught. And natural log of e is 1. So this will become natural log of r is equal to minus kt plus natural log of rt. So this is basically the equation. And for a straight line graph, you will go with, for example, if this is the equation, r is equal to minus k times t plus ln r naught. If we circle the dependent and independent variable, this is the dependent variable and this is the independent variable. The independent variable must be on the x-axis, the dependent variable must be on the y-axis, and when you make a comparison, then you see if you plot a graph of natural log of r against t, it would be a straight line with negative gradient. Gradient will be negative k. And y-intercept will be natural log of r naught. So these are the things you need to know. So on the left hand side, we have equations. On the right hand side, x is for straight line. And the first step is you have to decide how will you achieve a straight line graph. No writing answer. First of all, they will give you a space for drawing the apparatus and arrangement, whatever you have mentioned in your method. Then they will give you lines like this to write your answer. They give you lines like this to write your answer, and they will give you almost 1.5 page. So you have to draw here and you have to write here. But I will suggest you first complete the writing work and then go for drawing, because sometimes when you're writing, you get new points, but if you've already drawn it, then you cannot mention the new points. So what you will write in the writing part. First of all, let's discuss the main headings. The first heading is, you can go with headings, no problem. The examiner wants certain points in your answer, and if you have mentioned those points, then no problem. You can go with headings, or you can go with bullets, or you can go with writing of points, paragraphs, anything. Definition of problem will be your first heading. Your second heading will be method or procedure. Your third heading will be data to be, the third heading would be data to be collected. Your fourth heading would be graph, and conclusion, and your fifth heading would be safety precautions. If you look for the mark scheme, they will give you another heading that is extra points. But extra points is not something that you have to write separately. They are included in they are the part of the answer. When you will write the answer, you have to mention some extra details which will have marks, but those extra details are parts of the main question. They are the parts of all these headings. They are not something other than that. Now, what you have to mention in definition of problem? Definition of problem is about two things. Oh, sorry, about three things. List, first of all, independent variable. It is a variable that you are planning to change. To conduct the experiment, you will change this variable. Then select the dependent variable on which you have to observe the change. Dependent variable will be the one on which you have to observe the change. So select your independent variable. Independent variable. So basically independent variable is, you can understand from the question that which is the independent variable. However, if initially you have difficulty in identifying, after some practice, identification will not be difficult. Independent variable is the variable that you plan to change. Independent variable is a variable that you plan to change. Dependent variable, variable on which the effect of variable on which the effect of change of independent variable on which the effect of change of independent variable is to be observed. Is to be observed, that would be the dependent variable. That would be the dependent variable. Now the third thing is the variables to be controlled. You have to list them. You're not going to define them. You'll say heat, pressure is my independent variable, heat is my dependent variable. Or you'll say temperature is my independent variable, resistance is my dependent variable. You will not write any sentences. Or sometimes you can say that temperature, I will change the temperature and will see the effect of change of temperature on the resistance. So basically you're defining your independent variable and dependent variable. Now you will write variables to be controlled. This is for fair testing. You want the dependent variable only to be affected by the dependent variable, because if there are some other changes which could affect the dependent variable, then your results will be unreliable or doubtful. So you have to maintain everything else which can affect the dependent variable. So every quantity or factor that may affect the dependent variable other than other than you will not write these sentences in your answer. It is for your own understanding. Here you will name the control variables to be controlled other than the independent variable are to be controlled. Control means they must be maintained. Must be maintained must be maintained constant. Here you will list all the physical factors or other quantities which may affect the dependent variable should be maintained or kept constant so that its effect should not appear in the dependent variable. This is to ensure that the dependent variable only depends on this is to ensure that the dependent variable only depends on the this is to ensure that the dependent variable only depends on the independent variable and nothing else. And I should clear one thing. If your definition of the problem is correct, then the remaining parts will be correct, because the definition of the problem, although it has 2 to 3 marks, yet it's important as it will decide the remaining question will be correct or incorrect. Now you see, after your definition of problem, you will write the method or procedure. So method or procedure. In method or procedure, you have to write certain points, certain fixed points. These are the following points which you have to follow. Give method to change the, and you also have to mention the experimental arrangement. But the main points to be covered are give method to change the independent variable. You have to tell, I will change my independent variable by this method. Then you have to give method method change the independent variable. Then it's when you change it, you have to measure it. Method to measure the independent variable. So method to change the independent variable, method to measure the independent variable, and dependent variable will change on its own. Your duty is just to measure that. Method to measure the method to measure the dependent variable. So method to change the independent variable, method to measure the independent variable, method to measure the dependent variable. Then you have to find, then you have to find then you have to tell method to keep controlled methods to keep control variables method to keep the control variables constant. For all the methods that you have written, discuss merits and demerits. Method discuss merits and demerits of all the methods. Discuss the discuss the errors and discuss the errors and improvements. Discuss the errors and improvements in your method. Also discuss the range of values in your methods. Now, if I underline the extra details, these are the extra details. So these are the things which we'll discuss and they will be counted as extra detail. However, they are not to be mentioned separately. For example, if you're using a meter rule, it could be bent, it could have broken edges, it could be wrongly calibrated. So you will say that if you're using a meter rule, you will say that use meter rule. However, be careful, it could have broken ends, it could have wrong divisions mark, or it may be bent. To see whether any of these faults is there in the given meter rule, you can compare given meter rule with other meter rules for verification. So we have to mention these points clearly. Then after that, you have the data to be collected. Data to be collected depends on the equation or your axis of graph that you decided in your rough work. So data to be collected is already decided in your rough work because you know the axis of the graph. So according, so data to be collected according to data to be collected according to data to be collected according to your rough work that you already did. You will not write that, but according to your rough work, you know axis for straight line. So according to your rough work, you know the axis for straight line. So according to your rough work, you know the axis for straight line graph. Make a data table with column headings which must include those axes for straight line graph. For example, in the relation for resistance against temperature, we remember that R was, sorry, natural log of R, one second. We know that natural log of R was on y-axis. Natural log has no unit and unit of R is ohms, that is written in the bracket. And temperature is on the x-axis. So you need these two quantities for your plot. So you'll make column headings in which there are two things that you have to find mainly. So you'll find, for example, you'll say at temperature this much degree Celsius, you are reading the temperature directly. For resistance, you can go through current, voltage, and then you may have resistance in ohms, and then you must have natural log of resistance in ohms. So this is the data table in which you have mentioned the data to be collected. Then you'll go with so graph and conclusion. Either show the axis or write for generalized question plot dash on y-axis against dash on x-axis if it is a straight line, then the given equation, then the given relation, never say it is correct or incorrect. If it's straight line, then the given equation or relation so plot dash on y-axis against dash on x-axis. If it is a straight line, then the given equation is supported by the experimental so then the given relation will be supported by the experimental results. Never say given relation will be correct, incorrect. Just say that my experiment is supporting that. However, obviously, the human experiments may be uncertain. They could have problems. So 100% accuracy or reliability cannot be brought into the experiments done by human beings. So we'll say that the experiment results are supporting that, opposing that, all of that. Then we will relate relate the gradient and y-intercept to the constants to be found. And the last thing that you're doing is write any two safety precautions. And for better understanding of paper 5, we have to go with a real life, we'll go with a real past exam question and we'll solve that. However, this is the main body of paper 5 question number 1, and you have to fulfill the basic requirement, or you can say that if you know all of this, then you can get, if all of this is correct, then you can get about 13 to 14 out of 15. So students, take care. Khuda Hafiz.